look around, I see a world that's changing at tremendous speed. A new generation is committed to bringing technology into balance with the environment. The change can be seen everywhere. Take electric vehicles. We see them all the time on our streets. Companies like Hella are shaping mobility of the future. With energy management systems and thermal management solutions that make eco-friendly driving even better and more economical. There's no stopping climate-neutral drive systems. They are a perfect fit for our time and are just fun to drive. Thanks to engine recuperation, we have a much smarter and more efficient way to use energy. Infrastructures are constantly improving, which makes switching to electromobility even more appealing. I'm very proud to be actively shaping this change here at Hella. Our technologies help us reach milestones in sustainable mobility. Each of us in the worldwide Hella network plays an important role. We are all connected by our passion for turning fascinating ideas into reality and sharing our achievements with the world. Personally, I'm always amazed at how our concept of mobility has changed and everything that is now possible. And it just shows we can reinvent ourselves and make things happen. Not by waiting, but by actively shaping the future. This is our chance.
Hi there, Frank.
Hi, Pete. How are you?
I'm fine. And you?
I'm not too bad, thank you.
Good. Here we are, another Hella webinar.
And the webinar today is about enabling e-mobility.
Yeah. And you're Frank Brown.
I'm from the Listrik headquarters, and this is Pete Bradley.
From Hella Gutman Solutions.
Great video we just watched.
It really was. And it sort of encompasses everything we're going to talk about and how Hella's approach to e-mobility is.
And about how e-mobility is trending in the vehicle productions going forwards.
Yes, exactly. And what we're going to talk about really is to inform the users or inform the viewers about what it means for me. What does e-mobility mean for me?
And in the webinar, we're going to deal with the Hella holistic approach to electric vehicles in the future.
Yeah, not only that, but also market penetration.
The infrastructure will be required for the new vehicles upcoming.
Current regulations.
And of course, the vehicle architecture and the parts that Hella produce for these new electric vehicles. And
that really encompasses the 360-degree holistic approach that Hella has to enabling e-mobility.
So we've just talked about enabling e-mobility.
Correct.
And one of the most important things within that is battery regulations.
Yeah, well, regulations per se, Frank, there's quite a few of them. And they're very important for the manufacturers of electric vehicle batteries, not necessarily the vehicle manufacturer themselves.
Well, I started to read this EU regulation from July 23, and it wasn't easy reading.
No, it certainly isn't easy reading, but in fact, if the viewers want to, then they can scan the QR code above me here, and they can either download or read the regulation online.
So what does it actually cover?
Well, it is part of the EU wanting to create a circular economy and reduce waste of electric vehicle batteries. This is all part of the Green Deal, dealing with things like repair, replacement, refurbishment, and secondary use of EV batteries.
And for our viewers, what does that actually mean?
Secondary use?
Secondary use?
Yeah. Well, secondary use is actually taking the battery out of the automotive industry and not being used in a vehicle again, but being used, let's say, a stack of EV batteries at home, feeding your home electrics powered by solar energy or by feeding it into the grid.
So how do we understand how that battery can be reused?
Well, we need to talk about state of health, Frank.
State of health?
Yeah, state of health. A bit like the doctor gives you a state of health.
Okay.
We do that now with electric vehicle batteries. And in fact, Hella Gutmann Solutions provides a software solution for establishing and calculating the state of health of a battery. The state of health is a percentage of how healthy is the battery. So things like 90%, 80%, things like that.
So therefore, by doing this state of health analysis, we can see if the battery is working okay, whether it requires a repair or a replacement.
Well, there are actually standards being devised for that, and the Euro 7 regulation, which are the emission regulations from the EU, call for a standard of after 5 years the battery should have 80%, and after 8 years it should have 70%. Now this is a guideline for, very importantly, for the second-hand car market.
So are there any other obligations we need to follow?
Well, the second-hand car market, i.e. the electric vehicle battery, is one of the most important factors calculating the market value of that particular vehicle.
Okay.
Unlike in the old days, the ICE engines, petrol, diesel, and the mileage the vehicle is covered were the factor involved. Other factors that we need to consider, as you just mentioned, Frank, are things like a European standard taken from the battery regulation. An ISO standard is also being developed based on the UNECE directive, and most importantly, the battery pass.
The battery pass, how does that help us within the market?
Well, the battery pass is essentially done by the battery manufacturer, and all the information about that battery, the safety, how it can be used, when it needs to be repaired, etc., is all included in the battery pass. And this assists the whole value chain right down to from the manufacturer to the workshop, establishing all of the information about that battery.
So therefore, we can see that standard upheld from the original source through to the end usage.
Correct. Maybe not for the end consumer, Frank, or the driver of the vehicle or the owner of the vehicle, but certainly down to workshop level where they can then make a decision on repair, replacement, and again, refurbishment.
And that's great for our viewers to understand.
It is.
So, we've talked about enabling e-mobility. We've talked about the battery regulations.
Yep.
Now we should discuss about market penetration.
And that's these charts here behind us, Frank. So let's take a look at those.
So, these numbers from 2023, but we understand that electric cars have been in the market for around 15 years already.
Yep. Yep.
Yeah, and you see the development here in the charts, but the electric market is changing quite rapidly right now.
Are there any reasons for that?
Yeah. Pressures due to the climate change goals that are in the world right now, the perception and requirement of new technologies for the people they want to have going forward.
So that's, don't forget, Frank, an important factor about that is that 50% of the car park in 2050 will still be ICE vehicles.
And that's where you see that different countries are developing at different rates.
Of electric vehicles.
Implementing electric vehicles or hybrid vehicles at different times as they can within their country's requirements.
Okay, I see from the charts here that averaging it out over a year, it's about 50% new registrations sort of worldwide for these.
And I talk about different countries. If I take Norway as an outlier, Norway have at this moment in time over 90% of new registrations in electric vehicles.
Over 90%?
It's a very high number.
That's high.
The Norwegian government have put different incentives in place. Yeah?
And what are those incentives?
Lower VAT or no VAT.
Right.
They have cheap electric,
Yeah.
which makes it much easier for the consumer to move towards electric vehicles rather than internal combustion engines.
Okay, so what you're saying, Frank, is if we want to drive electric vehicles, we should all move to Norway.
Kom igen.
Well, like you're a Norwegian as well, Frank. We're now going to watch a short video all about Hella's strategy in enabling e-mobility.
So, we've just seen a great video showing Hella parts in an electric vehicle.
We have, Frank, and that's sort of demonstrating how Hella is keeping pace with technology and introducing more specific parts for electric vehicles, which means we're expanding our portfolio as any good company would do.
Not forgetting that electric and HEV vehicles still use a lot of additional parts.
They do.
For which purposes?
Well, you could have radar for ADAS, for instance, engine, you could have something like the intelligent battery sensor, and body parts, the classic Hella lighting, of course.
And are we making specific parts for electric vehicles?
Well, of course. I said we're expanding the portfolio for electric vehicle parts, and that includes parts for battery thermal management and battery energy management.
So earlier in our webinar, we talked about the battery.
We did.
Yeah, and how it can be used for repairs or replacement. So
you're talking about state of health.
The state of health, yeah. How does that work around the vehicle?
Well, of course, we don't just only have that, but Hella Gutmann Solutions provides classic diagnostics for electric vehicles in the same way as we do for ICE vehicles.
Okay. We've seen lots of different things in the webinar so far.
We have.
And it's all part of the Hella Holistic 360 approach.
Yeah, it is. And as you can see on here, we are not going to be just talking about parts only. That's only one element of the whole holistic approach that we have.
So other parts that we have are calibration.
Yeah, that's to deal with ADAS, cameras and radars and so on and so forth.
We have the support and hotline for the workshops.
Yeah, we've got about, we do have over 80 qualified technicians on the hotline, and they're answering between 2,000 and 2,500 calls per day from workshops.
And how does the Hella Tech World and Hella Partner World also support the workshops?
Well, it's an information portal, one for the workshops and one for the wholesalers. Hella Tech World for workshops, Hella Partner World for the wholesalers. And this is a 24/7 accessible portal for technical information, videos, and that sort of thing.
We also have then remote services that supports this.
Yeah, remote services is something that we offer the workshops, so they can do specific configurations on not just on electric vehicles, but also on normal ICE vehicles.
And there's lots of information that we are now imparting to our viewers. Do we then consolidate that in a training package?
Yeah, especially for electric vehicles, we've got the full legal qualifications that a workshop needs to actually be able to work on electric vehicles, and that's European-wide and also worldwide. And we offer that training through the Hella Academy here in Ervita.
And we still have diagnostic tools and offers in addition to that?
Well, as I mentioned, we have the state of health, and we also have what is called the MTHV, our measurement technology high voltage, which is specifically designed to safely work and do measurements on electric vehicles.
So then our holistic approach is not only for EV vehicles, but for all our products.
Every product range that we have encompasses this 360-degree offer for the workshops.
So I think that's quite an in-depth and comprehensive holistic approach.
It is.
Supporting many activities that we have.
It is. It does. But now, Frank, I'm going to leave and join Mario for the practical part of this webinar. And but we're not leaving you alone, viewers. You're going to have the delight of watching a video about what we talked about, our State of Health Pro.
So enjoy the video and I'll see you soon.
Will do, Frank. Mario.
Oh, hi, Pete.
Hi. How are you?
Oh, thanks. I'm fine. And you?
Good, good. Yeah, I've just come from doing all the discussions about Hella's enabling e-mobility.
Okay.
And we've come to you for the practical part. By the way, Mario is our chief technician when it comes to electric vehicles and everything that goes with it.
Good. No pressure.
So
for me.
pay attention. So what can we do practically? I see you've got a battery out of the car and everything like that. So take us through what workshops would get involved with.
Okay. Yes. I would say before we start with the battery part.
Yeah.
I have two things.
Okay.
First of all, the first rule that we have, what we have to keep in our mind and to pay attention.
Oh
to
yeah, I
that
wanted to shake your
is-
hand, didn't I?
Yeah, exactly. Yes, is safety first.
Okay.
Okay. We would like to say that directly at the beginning. For that, safety first. Please take care of yourself. Okay?
That's the reason we've got all these barriers around, etc., and that my hands not allowed to go over that.
I know that this is very hard for you.
It
Pete.
is, yes. I'm a hands-on
It's
guy. I'm a
very
hands-on
hard for
guy.
you, but exactly, all the chains, all the barriers, everything what you see here, all the marks are there to bring the information for the workshop, for the other colleagues.
Okay.
Come on, pay attention. Please stay away from that.
Okay.
Okay.
Good. I shall stay here.
Yes, please. And
Rooted to the spot.
not only you can go over there. That's also
Okay.
I'm fine with that. But pay attention to this, and all this is connected to the country-specific regulations.
Right. So
important.
not everybody would have it like this. Some maybe more, some maybe less. Just that our colleagues in other countries need to be aware of the regulations that Mario has just talked about.
Yes, of course. And the second thing, what I would like to say in that part here is, before we could remove a battery from a car, we must discharge and disconnect the high voltage system in the correct way. And this is from the manufacturer created.
So this doesn't differ country to country. It's manufacturer specific.
Yes, of course.
Right. Okay.
Please pay attention to this to handle the car in the correct way.
Okay.
Okay.
And for those of us who are fresh to this, where can we get this information from? Where can we find this information from?
This information is in the diagnostic tool.
Okay.
We have the mobility datas.
Oh, right.
And in this mobility datas, we find the complete manual, car specific, to disconnect, to discharge the system.
Okay.
In a safety way. We have a report for this in the very end, so that everything is at the correct place, and you have the report as a mechanic that you have done each single step.
You're talking about the vehicle technicians now. How do they need special training or?
Let me jump back into the part with country specific.
Okay. Very good.
Q&A. Yes, we have in each country different education levels. When we talk about Germany, for example, we have, when we are very picky in this, we have 4 different levels.
Okay.
The technician parts is 1S, 2S, and 3S. 1S is for normal work, 2S for disconnecting and remove normal high voltage components, AC compressor, for example.
Right.
And we have 3S. These are the guys who are educated to work on batteries.
To work on batteries. So there's a special qualification for batteries. And as I understand it, here at the Hella Academy, where we're actually doing all of this today, we are qualified to teach technicians up to the level for repairing batteries.
Yes, exactly. We can do that here in Germany on our regulations.
Our regulation, okay.
But to make this a little bit more clear for you out there for the screens, in front of the screens, when I move in a different country, it could be the case that my education is not accepted in the specific country. So please pay attention to that.
So it's not transferable, even if the regulations in that country may be lower standard than Germany. I wouldn't say lower standard than Germany, but different than the ones in Germany.
This is not a question of knowledge. It's a question of certification.
Good. And that's going back to our 360 holistic view of how Hella approaches enabling e-mobility, that all of this information we've just been talking about and the training, etc., is all included in that 360-degree holistic view on not just e-vehicles, but everything else, as we've said.
Yes.
So let's get to the bit of the practical part. Now we've covered your
That's great.
Safety is paramount.
But we have one single step left for safety, Pete.
Oh, what's that then?
PPE.
personal protection equipment.
Of each mechanic.
Right. Okay. Oh, they are large gloves.
Very large gloves, and
Difficult to work with.
a little bit.
You have to get
You
used to
get
it.
familiar with this,
Okay.
but it takes a little bit of time.
Okay.
Before you start working with these gloves,
Yeah.
you must check that. Very important.
This is the check for the gloves. Okay.
There's pressure.
All right. So
Be
we'll
sure
make
that there are no holes.
Yeah. Okay.
inside of the
I've seen that on some cartoons. It's a sort of
Yeah.
the head of a chicken or something
little
like
bit,
that. Yeah. Or a
It feels
baseball
little bit.
glove, something like that. Yeah.
Right. What is also important, we talked about that, I think, yesterday, the classification.
Oh, right.
Yes.
Okay. So there's a certain classification.
Exactly.
Right.
This classification must hit exactly the range of the voltage from the battery.
Right.
So when you have, as an example, you have a glove that is protecting yourself for 500 volts, and you have an 800 volt battery, you
Then-
need different glove.
Okay.
Okay?
So maybe it's best to buy the highest.
No, the
Classifi-
highest is up to 10,000 volts.
Oh, well,
And
that's.
you are like this.
right.
Okay?
Oh, well, that's working on
Yeah,
overhead cables and stuff.
Yeah,
like
exactly.
Okay, so you need
Class
to be
0.
sensible. Sorry?
Classification 0 is the normal one. This
Okay.
is 1000 volts DC.
And that information is also in our module
Yeah.
on the unit and also in the Hellatech world where you can find all that information.
Right.
Okay, that's good.
So
Good to know.
let's put these gloves on.
Yeah. I don't need gloves because I'm the other side of the barrier, aren't I?
You have the opportunity to wear
No,
rings
that's
and
fine.
your watches and all that.
All right, all that's got to go. Yeah, I noticed you got nothing. Even your wife's saying,
Well,
"Where's his wedding ring?"
Yeah. Please cover me.
Yeah, I'll do that. Don't worry. You're safe with me.
That's great.
I hope I'm safe with you. So, okay, let's have a look then.
So, personal protection equipment, very important.
Yeah.
Then I remove this isolation mat.
Okay, and the isolation mat is important just to make sure, because the battery is live, I suppose.
In our case here, I have opened the main cover from the battery.
Right.
The screws are not inside of the housing.
Okay.
Because I would like to save a little bit time with you guys.
No problem.
So this is the reason why I put this mat over to
Okay.
get the protection level from the battery higher. Okay.
Okay.
So we open that,
Yeah.
and after this,
Let you do that, yeah.
you have now a quick overview for the total battery.
Okay.
And with
And the mat goes back on as well.
Sorry.
The mat now goes back on as well.
Exactly.
Oh,
Because
okay.
what did I say? First rule is
Safety first, paramount. Okay.
Okay, how could we work now on this battery? This is simple. Please put the mat or a cover on the open battery.
Mm-hmm.
Why? This gives you the safety that you have, that you are not in the danger that something goes from your hands inside of the battery. Some
Okay.
tools, dirt, or whatever. Yes?
Yeah.
And we are just opening the part
Right.
where we are working.
Very good.
Okay?
Okay.
Just to give you an overview, what did we have here? We have a non-battery from a Toyota, okay, hybrid battery, no
Okay.
fully electric car, and
Still a big battery for a hybrid, though, isn't it?
it is a big battery, but this is also still a very old version, one of the first versions that was available.
Well, this sort of battery would be something that a workshop would encounter.
Yes.
The older batteries
Yes,
and have to
of
deal
course.
with them.
Of
Okay.
course.
Very good.
So, what did we have here? Let's talk about the structure. We have here on that side, we have the electric circuit for the battery. So when
There's-
the car is activated,
Yeah.
these electric relays
Relays,
are
okay.
closed
Yeah.
and bring the in that situation, the electric energy has the opportunity to arrive at the electric motor.
Right. So that's where the relays are closed. Just in a normal relay in a
Right.
12-volt system,
Right.
it's closed and it provides power.
Exactly.
Okay.
So just to make it to create a closed, complete case for that, when we disconnect and discharge the car in front, okay, we open
Yeah.
the disconnecting plug. Then these relays are the ones who gets opened.
They open up.
Or when the car has a mistake, the relays get
Okay,
opened.
they're not only relays for that, but they're also safety relays again.
Yes.
So
Exactly.
again, safety comes in paramount. Something's wrong. Relays are
open it.
Disconnect the high voltage from the vehicle.
Yes. In the modern systems, we have different settings for that. Sometimes with some airbag units on it to get it exploded to open it. What we also have, we have here the main part for storing the energy. So
So those are cells or modules or
everything, Pete. That is everything.
Right.
Included in this.
You say everything. Okay. So that you say that's a module.
Yes, step by right.
Okay.
This complete one of these gray parts here is one module.
And inside the module are cells.
Exactly.
All right.
Inside of these one module are 6 cells.
6 cells.
6.
Okay.
6 of them. And then we have, step by step, all modules connected in a row through the complete battery to get the complete voltage level high enough for the use case of electric driving or hybrid systems, recuperation or whatever.
Very good.
Okay.
Very good. Okay.
Then we have in this battery different temperature sensors, for example.
Okay.
For the
temperature sensors. So we're talking about the thermal management of the battery.
Exactly.
Well, just before we were talking about the portfolio of Hella being expanded and developed, and part of that is the thermal management. So very good.
This battery has a very, very simple thermal management because the storage energy level is not so high. In the most modern systems, BEVs, for example, then we have a higher complexity in this complete
So the
system.
thermal management becomes much more important the bigger the battery.
Sometimes the air conditioning system have to reduce the battery temperature and all that. Could be possible.
Okay.
So then we have here the black pipes. This is necessary to bring the fresh air inside of the battery for the cooling process.
Again, thermal management,
Yes. What is very important, we have now the structure of this battery, okay? It could be on a different car from a different brand with a different module, totally different. So we have different sizes, different material, different electric connection inside of this communication in the modern systems.
So a battery may not be a battery as a battery should be. It's different.
It could be very, very different. So it is absolutely important to know exactly what is going on inside before we start working. Okay.
I'm not too sure that we can actually see the temperature sensors from the camera view. Have you got a better way that we can show that? I see you've got another module at the
Here's a
back
different one, right?
Okay.
On that side, this is from the first generation of a Volkswagen e-up.
Okay.
Okay. This is a lithium system. What did we see here? We have one module.
All right.
And when you now see that size, when I put it over here, the battery and one module, and in the main battery are 17 of these modules.
Wow. But that's a pure battery electric vehicle.
Exactly.
So
more energy.
The difference in size between a module on this battery, hybrid, and that battery, pure electric, much higher energy capacity, etc.
Absolutely.
Okay.
And what we have here the temperature part.
Okay.
Okay. And we have here one this side. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cells.
12 cells.
And the single cell is looking like this.
Okay.
Or to show it for you a little bit more in detail, like this.
Right. Okay.
This is one cell. We have plus, we have minus.
Yeah,
we have
red and black as usual.
Here a part that gets broken when the pressure inside of the battery is too high. This is a safety feature to get the pressure in an accident or
pressure relief valve, just like air conditioning.
Exactly,
right. Okay, understood.
But this is just usable for just one time.
Well, it's a one shot.
After that, we are back in this game to repair a battery.
Very good. So let's have a look at how we start to look at repairing a battery then.
Okay, we come back to this game.
We just before this, the viewers saw our video on State of Health Pro.
Great.
So this is where the State of Health has dictated there's something wrong with the battery, you remove the battery, and now we're going to go into what we're looking at.
Yeah.
Okay, very good.
But this SOH Pro part is very special for you because on your work was the battery regulations, right?
Exactly.
Exactly. Your part. Yeah. Okay. What I will do now with you guys is to open the side here.
So that's now revealing all the connections for the individual modules.
Okay, right.
Okay.
Absolutely correct.
Yep.
Modules. So I will open the opposite side, the other side as well.
Yeah. I mean, we can't see this on the camera's viewers, but essentially this side is the same as that side.
You must give them a warning for a spoiler.
Spoiler alert. Okay.
Okay, we have here the different contacts, and what could we do now? I open on the diagnostic tool,
Okay.
the measurement part,
Yeah.
just to keep it look.
Okay. I see you're you're using our MTHV, which I talked about as well. Part of the equipment you need for electric vehicles,
Yes.
measuring technology, high voltage, and our guided measurement system.
Yes, and we have also low voltage implemented
Right.
in this part, because without low voltage,
There's no high voltage.
Absolutely.
Correct.
All the communication is done by low voltage. Without that, we don't have an opportunity to handle this.
Very good.
What I will use now here is not the guided part. What I would like to create with you is a free high voltage measurement.
Right.
So I
Because
open
we've
this part.
the guided part is when you're guided through disconnect.
Right.
Okay, very good.
We are still working for new data and solutions for our customers. Next step could be the data for removing batteries from cars and to add the battery, bring the battery back in the car.
Okay.
But we look what's going on in the market to create it step by step in the case what is necessary.
Good.
So then we have here the part with voltage. I start the measurement, and now we see at the green button at the bottom, we have continue by pushing the button at the high voltage test lead.
That's the big button on the positive side?
Yes.
Okay. And
Put it
what's
on
on
there.
the screen are... Very good. What's on the screen is safety instructions? Again?
So good, Pete. So good.
Okay. There you go.
Yes,
Work on
we
electric
have-
cars is only allowed to be done by specially trained persons.
Yeah,
Very
yeah.
good. Touching of energize, which I'm not going to do. Yeah. So that we're always emphasizing safety before every step that we do.
It sounds so funny when we are both talking about this in this content here, but one is very, 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 very important to keep it in your mind. When you see the damage, it's too late.
Yeah. Yeah.
Maybe it's over for you. You are done. Okay?
Yeah.
Because
Game
this
over.
energy that is stored inside of this, that's too much for your body.
Throw you across the room. Okay. We don't want anybody thrown across the room, so we shall stick to the safeties. Very good.
What I've done now, I have skipped this page, and what we do now is a test probe check. So I put the both test probes together and push this button, and the system creates an automatic test probe check to be sure that the system is from the test probe on the plus side up to the test probe on the minus side, totally okay and ready for use.
And we get a green okay, and every measurement we do will get a green okay or not okay, depending on how you interpret it.
Yeah, this is different.
Okay.
Depending on the function. In the guided measurement,
Yeah.
you get an automatically evaluation. Green, yes. Red, faulty. Okay.
Right.
In this case, you have to decide what
You decide.
So
Okay.
the test probe check is green. The system says okay.
Yeah.
After that, each part is with a gray mark. You have to decide. It's up to you. You are the responsible, or I am the responsible person for this evaluation to decide what did we have to do, what
Okay.
is necessary. So
Okay.
we start now with the measurement.
Yep.
I go to the first two contacts, and
Okay.
we have there 14.865 volts.
Very
But
good.
how many things we are now measuring, Pete? What do you think?
We're measuring 2 modules.
Exactly. This is very
Okay.
important.
So we're going positive on one module to
Positive is the start.
a negative. Okay, yeah.
Then we
normal
go to the
normal
outside.
measurement, positive,
Remember,
negative.
they are connected in a row.
Yeah.
That
So if you
means
go
when
to
I
the other
go here-
side, yeah.
To this side, come on. And to this side. Then we have 7 point whatever volts.
Yeah,
Now I press-
7.46. Yeah, 7.46. Yeah, it's around that. But the voltage measurement is very exact. You know, it's 7 and 3
Yeah.
digits after the comma.
This is very crazy in these systems. I will talk about a little bit later about
Okay.
that topic. why is that so precisely,
Okay.
and why is that necessary. But it's a total logical reason why. So
Okay.
now we have measured one module.
Okay.
I pushed that button to save this value
Right.
in the report.
Yeah. Oh, so as you do all these measurements and you press the button, that measurement is saved, so you can evaluate also afterwards.
Yes.
Very good.
Important. The car must be selected in the car history.
Okay. Yeah. Very good.
So we have here start with plus, and when I start now, continue to the next minus part, we have up to 30 volts.
Okay. So that's twice.
These are
Do
now 4 modules. Then we
Okay.
go next one, next minus part.
Okay.
We have 44. The next 2. Then we go into the next contact. Then we have 60. And when I go to the last one, then we get 133.7 volts.
Right. But that's not the last one.
This is not the last one in the normal logical thinking.
Oh, I'm not thinking logically, obviously.
In the normal, you are normally logical thinking, and this is a great thing. This is an example why it is absolutely important to know what you're doing in the battery.
Okay.
Because look at this. We have here in the battery a split. Okay.
A split.
When we have here these relays open, the car gets splitted in 2 sides. The battery, sorry,
pack,
not
yeah.
the car. The battery pack is splitted in 2 parts
Okay.
because this reduces the total voltage level inside of the battery. So we don't have 300 volts in total. We have whatever 2 times
Yeah.
150 volts. Reduces the danger and creates a little bit more safety.
Again, a bit more safety. So
Yes.
some manufacturers may even split it down even further if they feel that's a higher safety factor.
This is not so often. This is a special behavior of this battery
Really?
technology. Okay. When we go back to this one here,
Yeah.
nothing is splitted.
Okay.
You have the whole time 400 volts available,
Wow.
full power between HV plus and minus.
Wow.
Okay?
Okay. Yep.
Cool. So then let's jump to the point with the 3 numbers behind the comma. Okay?
Let's talk a little bit about this, because this is just the measurement.
Right.
But you would like to know something about battery repair, right?
Yeah, certainly. Yeah, that's
That
what
was the main
we're
part.
trying to ascertain here.
Yeah. When we would like to try to repair a battery, then we must work very precisely for the balancing. And what is the balancing now?
Okay, but before that, the measurements that you've done, if there was a measurement that didn't seem right, was lower or whatever, then you would suspect that that module needs changing.
This is a good thing. What is the critical value?
Right.
It is manufacturer specific.
Okay. So
Sorry.
again, we look at our e-mobility module and see what the
Must find
manufacturer
this
says.
information. Right.
Okay.
It could be that you have 0 volts, then you
Yeah.
can be sure that this module is done. So this done.
Yeah,
This
all
is
right.
not
I mean,
possible to bring it
Yeah.
back in the game.
I mean, 0 volts would say to me that there's something wrong with it. So
Absolutely. But sometimes you have whatever 24 volts in such a big module like the e-up one that I have here. So is 21.7 a better result? And this is exactly where we must spend a very detailed view in this part
Okay.
and this situation, because the balancing has the goal of
balancing. Wait a minute. Balancing that. What does that actually mean?
to bring all cells on the same voltage level
Right.
to reduce inner resistance inside of the battery to keep the car or the battery for the driving process easy as possible in the situation for a good performance.
Okay. Balancing to me is sort of, you stood on a seesaw and you're doing this. It's got nothing to do with that really. The principle's the same, but so is special equipment required?
For the balancing process, what we do in a repair situation, yes, there
Okay.
are specific devices who create this balancing, because these parts have the opportunity to bring the new module with 3 numbers behind the comma at the exactly voltage level like the old ones. They will still be in the battery after the repair
Right. So
process.
we put a new module in, and the balancer's objective is to balance the old ones and the new ones, and so. Is that then done in the vehicle, or is it done outside the vehicle?
This is the balancing process that we do in the way from the balancer is done outside of the battery. Okay. But we also can do that. Some cars have the opportunity to do it with a specific software from the manufacturer, also in the connected. But it takes a very long time. I've seen this at a Skoda. It takes nearly 2 weeks for this small balancing process because the current is very, very small to bring this at the same level like the other.
Okay, but the battery is still okay to be used.
Yes,
yes. Okay. So how do we connect to the battery to do this when it's in this situation where it's not in the vehicle? How do we connect to do that then?
For that, I would say we go a little bit more in the part of the more modern systems.
Okay.
By the way, this is absolutely possible to touch that because we don't have a high voltage level here, okay? 24 volts in total.
Ah, okay. So that doesn't fall into the high voltage
regulation
in Germany.
Pay attention to the country-specific part.
Right, so it could in other countries. But then again, and you're allowed to handle it without gloves and without the protective screen and everything like that. Okay.
But just please work very carefully with that. There's a lot of energy inside. Okay. So we have the different contacts. We have minus,
show the viewers a bit.
We have
that. There we go.
The minus contact.
Okay.
Maybe you go a little bit about this direction.
Yeah.
We have the minus part here.
Yeah.
Then we have on the opposite side the plus contact.
Quite heavy, isn't it?
Yeah, a little bit. But good training. And we have here, very important, an analog contact for the communication.
Ah, okay.
It is not possible to use a normal battery charger to balance this module.
No, obviously,
to say it very clearly.
Obviously.
Okay, we need the contacts plus a minus, and we need the communication.
Right.
The really modern systems have a digital communication. There's a data bus implemented in this module.
Right.
Okay. And what is also the case, the high voltage part is developing very, very fast. So we have a lot of changes. You see that in your battery regulation.
Yeah, yeah. So they're constantly moving, and we're going to, the workshop will have to deal with different technologies coming up, different ways of balancing, different ways of repairing, and that we as Hella Gutmann Solutions and Hella are keeping ahead of that, making sure the workshops have got information like the e-mobility module in there or the Hella Tech World, keeping people or workshops up to date with what's happening and how to repair.
This is just balancing and remove a module. What we also have is the part with a leak test.
A leak test?
When I close the battery, we must create a leak test to be sure that there's no leak in the housing, that there's no opportunity that water can get in the battery. Where is the battery stored in the car?
I was thinking more of cell fluid leaking out. But you're talking about keeping it safe from the ingress of water.
Yeah.
Ah, okay.
Yeah, and this is also a very important topic where we are working at and looking very precisely what is going on and what is necessary for the workshops.
Excellent.
Okay.
Very good. Thank you very much, Mario.
You're welcome.
That was very informative. I hope you all gained something from that, and that Mario was very competent in showing us exactly what we can do, and that's why we have him as our chief instructor for electrical vehicle technologies here in the Hella Academy. Well, Mario, I'm going to shoot off now.
We see us later.
We will see us later, no doubt. I'm going to go off now, and I'm going to meet the people from the OE. So I'll have more information about what future technologies are coming up and what our Hella OE side are doing for electric vehicles.
That sounds great. Have fun.
Thanks very much, sir. Thanks very much, Mario. Bye-bye. Hi there.
Hi.
And you are?
I'm Benjamin. I'm from Energy Management at Hella.
Energy management, all to do with hybrid vehicles, electric vehicles, that sort of thing.
Correct.
How long has Hella been involved in this sort of technology?
Well, it all started with the intelligent battery sensor, which is on a lead acid battery. But here today we have components that are mainly lithium-ion based.
Okay. Yeah. Oh, very good. So this marvelous display. What does it actually tell? Well, give me a sort of an overview of what it is.
Well, it shows a powertrain. Actually, two powertrains in one.
Two powertrains in one.
Correct. On the one hand, we have the mild hybrid powertrain. This is 48 volt based.
Yeah.
The main source of energy would be still a gasoline engine.
A gasoline engine,
exactly. Charging then a 48 volt battery.
Okay.
And by that, then also a 12 volt battery system.
Okay.
So it's both in one.
Okay, what's the purpose of having both in one? Is it just for demonstration purposes, or
the high voltage, which we discuss later, maybe, and the 48 volt? Yes, that's just to have both.
But
in one.
It puts the Hella OE competence, showing what we're all involved in.
Correct.
Well, let's go through a few things then. You just mentioned mild hybrid, so
yes.
Why don't we start with that?
Yeah, correct. We can do. Mild hybrid basically means that we are able with a engine and a 48 volt starter generator to already have features like electric driving, but only in a small scale.
On a small scale, yeah.
This is stored then in the 48 volt battery, the energy, the higher energy that we need for that. Here in this case we have a power pack, which is a combination of the 48 volt battery itself,
right,
and the DC-DC converter that is needed to transfer the energy from 48 volt down to 12 volt.
Okay. Mild hybrid is sort of the start-stop system?
Correct. Yeah, it start-stop and a little bit more. So you can also do sailing with that. So you can already, while the engine can be switched off, even while you are still driving.
Okay, so coasting and that, yeah?
Coasting, yeah, exactly. Okay. And also you have higher power demands with these 48 volt systems that can be used here with the 48 volt battery.
Excellent.
Still, you need the 12 volt battery, which we also have here.
Yeah. Okay.
So that's then the 12 volt loads and the 12 volt lithium-ion battery.
So in a mild hybrid start-stop system, we've got 12 and 48 volt, and so a split system.
Exactly.
Okay.
Exactly.
And how do we charge the batteries then? How are they?
Yeah, for 48 volt, this is just done by the starter generator, so the e-machine.
E-machine.
48 volts that is then powered by the gasoline engine.
Right.
It's just the higher power demand that we need for all the features of luxury cars, for example, where 48 volt is needed.
Very good.
Yeah.
Very
and
good.
we have 48 volt loads. Yeah, for example, there are loads on 48 volt. Could be heating. Could be something with a suspension.
Seat heating in the winter when you need to drive nice in the car.
All of that could be powered by that.
Okay.
And in addition to that, we also have a high voltage system in here.
Yeah.
But they are more or less just for demonstration. So we have both in one. But here, of course, the main source of energy is different. It's coming from the outside. It's the charging.
Okay. Can we have a look at the simple circuit for that then, for the electric vehicle?
We can do. So here then maybe starting with the charging itself, so where the energy comes from the outside.
Energy management. Yeah, okay.
Exactly, that would be here. It's just flowing in, the energy, but basically it's coming from a charge pistol. Yeah.
Okay.
And the first thing that is to mention here is the actuator that can lock this charge pistol, which is this one. It's a micro actuator, also coming from Hella. That makes sure that you charge and nobody can unplug your vehicle.
The interlock. Well, I've been driving a full electric vehicle for the last 5 years, so I know which one I've got to undo this plug before I can do this plug. So that's all very safety related, because we're dealing again with high voltage, as we saw with Mario and his practical examples there.
All the safety starts here. Exactly.
Very good. So this is the
battery, but before any power comes to the battery, we have an onboard charger here.
Okay.
That is the high voltage onboard charger that transfers the energy coming from the grid to the battery.
All right.
So it converts the energy on the one hand, and in future it will also be capable of having power to grid functionality, so that the energy can be taken back from the battery to the grid.
Okay, so this is all to do with the energy management, being green and all that sort of stuff.
Exactly. You don't need, when you have solar power at home, you could store energy in your battery and you could recharge your house by your own vehicle.
We actually talked about the secondary use of electric vehicle batteries. Yeah. So that would be sort of using those at home and being charged by solar power, which then charge your car, so it becomes all this circular stuff.
That would be the second life. Here we are in the first life already talking about such a feature. We are currently working on downsizing, decreasing size and weight of the onboard charger. You see, these are very big components, so weight is an issue here, and the weight to power ratio, which we want to, of course.
So that would sort of reduce the, not reduce, but increase the range of electric vehicles, lighter components, and more efficient components,
and lower costs.
Lower costs as well. Okay.
Yeah, and the next, as you already mentioned, would then be the battery.
Is the battery,
the core component. This is a pure EV battery that we have here. It's a small one of a smart car, so that's why it's a bit smaller. Usually they are under the whole body of the vehicle when they're bigger batteries, but this is a quite handy one.
Is there any special things that we need to mention on here?
Yeah, so we try to make this visual here, for example, with these mirrors here, so that you can see
inside the component. Very good, yeah.
So usually
these don't get fitted to the car, the mirrors. Okay.
not
very good. So it's a sealed unit.
Exactly, it's sealed. Right. So usually these cutouts that you see here are also not there for sure. So that these parts are not accessible. Only the connectors for sure. And there you already mentioned the interlock that is then protecting anybody who is working on the battery. But here we have a sneak peek inside on the top and on the left and on the right side.
And under here,
Exactly. On top we see here the current sensor, which is very comparable to the IBS intelligent battery sensor that you mentioned initially. It's the same footprint, but we use it here for high voltage applications.
So is it the same sort of technology?
Exactly. So it's also a shunt-based current measurement that we use here. So the energy is flowing, or the current is flowing through, and is then measured. Exactly, to determine the state of health and state of charge of the battery, and the core, let's say the brain of the battery, which then be this battery management system. The unit here, that's the main component communicating to the outside. Okay, and that battery management system would be something that we would access with our diagnostic unit to measure the cell voltage, the module voltages. Exactly. So it provides all the necessary information about the state of health and all the, let's say, internals of the battery, temperature and current. And on the bottom side, we have here it's also only visible in the mirrors. These are cell controllers. So each cell which is inside this battery is measured individually for its voltage. And also the temperature measurement is done for the battery to see if it's in a safe state. And the contactors can be opened. So the contactors, which would be let's say the switches to switch the battery off and on to the rest of the vehicle. That's the main purpose of the battery management system, to decide to switch on and off the battery. Okay. What else can we show on this? From here, the energy then flows after charging to the battery. It flows then, of course, on the one hand to the DC-DC converter again. This is a high voltage DC-DC converter. Function is more or less the same. It converts the high voltage, so 400 or 800 volts, down to 12 volts. So we have still a lot of 12 volt. But there's still a 12 volt battery fitted, isn't there, to the vehicle? This is the same here. That's that's more or less the pivot point. That's the component that is relevant in both. So the 12 volt board net is still available, still needed. And for lighting, for everything, 12 volt is still right now the voltage level that is standard in the market. So the 12 volt battery is still needed, and this component converts the high energy, high voltage to the 12 volt. Very good. And besides that, of course, energy is also needed for all high voltage application. Main application would then be the engine, or the emission, the electric motor. Correct. And since all of that conversion and also the battery itself needs to be in a safe state and in a safe environment, that's where the orange cables come in. Exactly. Very good. It also has more or less the battery and also the other components tend to like the same temperatures as we humans do. That's why we have to cool them. Or heat them, depending on in which. So that goes into thermal management then. Correct. Exactly. And for that we have then here the coolant control hub, which is the core component to provide the right temperature to all the high voltage components. As you see here, the circuitry is flowing to all the components that we just discussed. And the special feature of this, as I've learned, is that it's one hub that can control many circuits. So you don't have to have 5 different circuits being controlled, and with pumps and with temperature sensors. It's all done by one unit. Correct. It's centralized. It is actually managing 3 different circuits. On the one hand, for the power electronics, they want to be cool. For the battery, which might want to be heated or cooled depending on the outside temperature. Is important when you're talking about electric vehicle batteries. Yes, I've learned that one. The interior, so the cabin temperature is also handled by that. It's very efficient because it's in one place. It is all components that would be needed and in the past were spread around the vehicle. So smaller components that you need to access, and the integration of that is much easier for the OEM, and that later on also to access that at one point makes sense. So it is efficient, it is smaller, and it's one component. If it goes wrong, it's changed, and it's not 10 or 15 other components that you need to change. As you see, they are all mounted, so some of them can be exchanged like that, but they're in one place. So you can adapt it to your vehicle's thermal management with 2, 3 or 4 circuits, that sort of thing. Yes. Okay, great. Good. So basically, these are the three circuits or the three features that we want to show here. A lot of components, as you see, are coming already from Hella.
Yeah.
We're working on improving them, but that's basically our portfolio.
Any other components that Hella is working on, or is it just the thermal management, energy management side, or?
Well, now I'm by heart an energy management guy,
okay.
So that's why
you're full of energy. I can tell.
Exactly, that's what I'm main focused on.
Yeah.
But I mean, a lot of components that you see here, or also that Hella in general has, are featuring EVs or combustion engine vehicles. So it's not really focused on that. But energy management, of course, is looking more in the future of EV
vehicles. Yeah. Okay. Great. Well, I think our viewers have got some very good information about what's happening on the OE side of Hella, and obviously when things happen and they are developed, then they'll eventually end up in the aftermarket. And we also get a lot of information on the technologies for e-vehicles from guys like Benjamin. So, Benjamin, thanks very much indeed.
Thank you.
And I'll see you soon.
See you.
Bye.
Bye.
Oh, here we are again, Frank.
Back together again?
Yeah. Almost at the end.
And how was your practical experience?
Practical was really good. Mario did a great job in showing us all the practical aspects.
So, as with all our webinars that we've done, I find it very informative, not just for me, and I hope the viewers also find it informative about the different things that we have in place here at Hella.
Yeah, well, let's just summarise that for the viewers, shall we? First of all, we had the introduction to enabling e-mobility from a Hella point of view.
We looked at the battery regulations.
Yeah, and the standards, of course, to that as well, all the regulatory things.
The overview of the developing electric vehicle market.
Yeah, the portfolio production and portfolio development within Hella, especially for e-vehicles.
The comprehensive Hella products that we have in place to support electric vehicles going forward, and the normal ICE vehicles.
Exactly. And we also had the Hella 360 holistic, which, if viewers are interested, then please look at the Hella Tech World and Academy, and you can do that by scanning the QR code just here.
And you just had a look at the glimpse into the future for the OE and Hella relationship.
Yeah, so that was very interesting to see how the OEs are developing, and obviously we can profit from that sort of information. And don't forget, the practical application that I did with Mario was talking about the hands-on on the vehicle with the tools, such as the MTHV measuring technology, high voltage.
So going through all of that, what is the message that you would give to our viewers?
Well, the thing is that some workshops are very reluctant to approach EVs. They see it as being in the future and a bit too complex. So we're not go to this change. So it's coming up. So with the Hella offer, we believe that we are not only enabling e-mobility in the terms of vehicles, but also enabling workshops to embrace the change that is coming very rapidly. So get on board now.
The future is now.
The future is now.
I'd like to say thank you very much for our wonderful webinar.
Thank you, Frank, as well. It's been a pleasure again, as always, presenting the webinar with you.
Thank you to our viewers. I hope you've taken a lot out of what we've given you today. Any questions that you have, the information is provided for you with the training or the Hella Tech World Hella Academy.
Exactly. And of course, at the end of this webinar, you have the chance to ask us questions, and the webinar will also be published on YouTube and again on the Hella Tech World. So for now, take care and drive safe, especially electric vehicles.
Thank you very much.
Bye-bye.
Take care.